Welcome to The Explainer. Today, we are diving into one of the biggest headaches in AI, how to stop your applications from just making stuff up. And we're going to look at a really clever coding pattern that solves it. All right, here's what we're going to cover. We'll kick things off by really defining the hallucination problem in production systems. Then I'll introduce you to an elegant solution called the LLM Judge. We are going to walk through the actual code to build one yourself. And then, the best part, we'll look at the incredible results this thing can deliver. So, first things first, why are we even talking about this? Well, Retrieval Augmented Generation, RAG, is an absolutely fantastic way to build LLM apps. But it has a serious trust problem. I mean, you really have to ask yourself this question and be honest. For any team putting LLM applications out there without the right safety nets, the answer is, unfortunately, sometimes yeah, it is. Think about this number for a second. In a standard production RAG pipeline, that initial hallucination rate, where the AI literally just invents facts, can be as high as 18%. For any serious application, it's not acceptable. It's a massive blow to user trust. So how in the world do we fix this? Well, the solution is as simple as it is brilliant. We're going to use another AI to act as a fact checker. Let's see exactly how that works. The concept has a name. It's called LMM as a Judge. It's basically a design pattern where you set up a second specialized LLM. Its only job is to check if the main AI's answer is 100% supported by the documents it was given. No outside knowledge allowed, just the facts. So this process adds this brand new safety net. You see it right there, step 4, verification. The judge slots in as this critical quality gate just before the answer goes out to the user, giving you that final layer of fact-checking. Okay, let's get our hands dirty and look at the code for a really basic version. This is the simplest way to get started, and you'll see it works surprisingly well, right out of the box. We kick things off with a simple Python class. Now, a couple of key things to notice here. First, we're using a fast, cheap model like GPT-4o Mini, and second, and this is crucial, we're setting the temperature to 0. We want this judge to be as deterministic and factual as possible. No creativity allowed. And the heart of this whole thing is this super direct prompt. I mean, there's just no room for misinterpretation, right? It asks for a dead simple binary output. Is the answer fully supported by the context? Yes or no? That's it. Now, while that simple yes/no string output is a great start, it's not robust enough for a serious production system. A simple string like that is brittle. It can break really easily. Let's see how we can level this up. This, right here, this is the whole problem with trying to parse simple strings. If the LLM deviates even a little bit from that strict yes or no format, your code breaks. We need a much, much more reliable way for our AIs to talk to each other. And the solution is Pydantic. It's an absolute game changer. By defining this little Python class that inherits from base model, we're creating a strict schema. We're forcing the LLM judge to return a structured JSON object that perfectly matches this schema. This completely wipes out any parsing errors. And I mean, just look at the difference. It is night and day. We go from a flimsy, fragile string to this rich, validated, machine-readable JSON object. Now we don't just know if an answer is wrong, we know why it's wrong and with what level of confidence. That's so much more powerful. This code-first, schema-driven approach is amazing because it means you can build a whole library of these copy-and-paste ready rubrics. You can make different judges for different tasks, one for facts, another for relevance, maybe even one for making sure you're following regulations. Okay, so we've seen the theory, we've seen the code, but the million-dollar question is, does this actually work in a real-world production environment? Well, the results are pretty dramatic. So implementing the LLM Judge cuts down hallucinations by a massive 79%. It takes that error rate from a really scary 18% all the way down to a much more manageable 3.8%. And this has a direct impact on the people actually using your app. With more trustworthy answers, customer satisfaction scores jumped by 37%. That is a huge win for building trust. Now, I know what you're thinking. Doesn't this extra step slow everything down? But check this out. The P99 latency, meaning 99% of the time, this check added only 182 milliseconds. That is a tiny price to pay for this level of quality assurance. When you look at the full production benchmarks, you can see the system meets or exceeds every single target for a reliable enterprise-grade AI service. From accuracy and latency to a low false positive rate, it's green across the board. And what's really great is that deploying this isn't some giant all-or-nothing project. You can roll it out in phases. In week 1, you get that immediate win by catching basic hallucinations. Then, over time, you can build up to a full monitoring and testing pipeline. And this is what the final architecture looks like in production. It's a robust, resilient system with automated quality gates, monitoring, alerts, and fallback logic to make sure your AI always stays on the right track. So the key takeaway here is that this isn't some future research project. This is ready for production right now. Using Pydantic to build a judge gives you immediate, structured quality assurance that can bring your AI application up to the reliability standards of any enterprise software. And this leaves us with a pretty fascinating thought to end on. We are clearly stepping into an era where automated systems can guarantee the quality of other automated systems. This doesn't just solve a problem for LLMs, it fundamentally changes how we think about building and trusting complex technology from now on.